let's graph another quadratic function. These are actually kind of fun. Sure. Don't you agree? All right. We've got g of x this time instead of f of x, just for something different, equals the opposite of x squared plus 5x minus 8. So remember where we start? By finding that vertex. And it's in ax squared plus bx plus c form. And remember, I can always slip a 1 when the coefficient of a variable term is missing. I can always slip a 1 in there. And so I'm going to go off to the side and make my list. A is negative 1. B is positive 5. And I don't need C because I'm just finding the vertex, not solving a quadratic equation. Alright, I go grab my vertex formula. X equals the opposite of B, and the opposite of B will be negative 5 over twice A, 2 times negative 1. Alright, let's simplify this. We get negative 5 over, what, negative 2? And a negative divided by a negative is positive. And if I use my calculator or my brain on that, 5 divided by 2 is 2.5. And again, it's positive. So, for our vertex, we've got the x value right now. We know it's 2.5. And we want to find the y value. Alright, so that's finding your maximum and your minimum. How do we do it? We put the 2.5 into the function where x was. We find f of 2.5. So let's do that. Take out the x's. So negative 1 blank squared plus 5 blank minus 8. Put in the 2.5. 2 5/10. Alright. Use your calculator or use your brain. Let's use a calculator. I know 2.5 squared is 6.25, but and that's going to be about 12.25, but let's practice using the calculator. So negative 1 parentheses 2.5, close them, square that, plus 5 parentheses 2.5 for times, and subtract 8. Alright, we get, I'm going to double check that. We get negative 1.75. Just make sure I calculated that right. Go back and take a look at everybody up there. 5 was our B value times 2.5. Yep, that all looks good. Alright, just double checking to make sure. So negative 1.75. So not going to be fun to graph this one, but I do have my x and y value for my parabola. So, let's graph those right now. It's going to be a little tricky, but if I go right 1, 2.5, you know what? I wonder how big these are going to get. I'll tell you what, let's make our t-table first and see, maybe we can go up by halves on our grid instead of by wholes, and that might help. So I'm going to put 2.5 in the middle of my t-table and negative 1.75 the output. And I want values on each side of that. Now, I'm not going to go up by whole number by one whole because I want integers here. So I'm just going to go to 3 and 4, and that's perfectly fine. And on the left side then, I'm going to use 2 and 1. So values on each side that are nice integers are the best ones to work with. So remember what we do next? We find the outputs for these inputs. So I've already got the function in my calculator. Remember I had put 2.5 in there, so now I'm going to delete that and put in a 3. Okay, and go over here and delete that, delete, and put in a 3. So we're putting the input 3 in. Let's see what we get for an output. We get negative 2. Alright, let's go over here and put the 2 in. If we're doing this right, we should get exactly the same answer. Okay, putting 2's where the 3's were. And we do indeed get negative 2. So that tells me I'm doing this right, because remember, it should be symmetric. Alright, let's put the 4 in now. And that should be a new value. and we get negative 4. Now if we're doing this right, when we replace the 4's with 1's, we should again get a negative 4, and we do. Okay, so there's our input and output table, and let's go ahead and graph these now. Because I only have to go as low as negative 4, what I think I'm going to do is go by skip spaces. So I'm going to go 1, 2, this way, negative 1, skip 2 spaces, negative 2, skip 2 spaces, negative 3, skip 2 spaces, negative 4. So skipping 2 spaces all along my number line. And then that's for the x and y values, or excuse me, for the x values. I'm going to do the same for the y values. 1, 2, 3, negative 1, negative 2, negative 3. Remember, you only need to number your x and y axes when you're not going by 1 unit at a time. Okay, so the value 2.5, negative 1.75. So 2.5, and then down 1, there's 1.5, and here would be negative 1.75, halfway through my grid line. The value 3, negative 2, right 3, and down to negative 2, just a little bit lower. The value 2, negative 2, right 2 and down negative 2, and we can start to see our parabola taking shape. 4, negative 4. Here's my 4, and down 1, 2, 3, negative 4. And the value 1, negative 4. 1 and down 2, 3, 4. Okay, I've got my matching points, and it's an upside down parabola. And why? Because the value in front of the x squared term is negative. This is why it's upside down. I forgot to say whether it was a maximum or minimum, and it is a maximum at negative 1.75. This is my vertex, and the maximum is here, 2.5, negative 1.75. All right, there you have it.